Let's do some more with scientific notation. One nice thing about scientific notation is that it multiplies and divides really easily. However, it does not add or subtract easily. So if you want to add or subtract numbers, you want them in decimal form. But for multiplying and dividing, it actually works pretty good to leave them in scientific notation. So let's see an example of that being the case. The reason it works so well is because of the commutative property. So remember, commutative property says that I can write multiplication in any order. I can rearrange the order. So the commutative property of multiplication allows us to switch the order. And that's exactly what I'm going to do here. Just because they're acting like 5 and 10 to the fourth are joined together, if they're just multiplied, I can move them around. And same with 6 and 10 to the eighth. Those are just multiplication. So I'm just going to move this around to 5 times 6 times 10 to the fourth times 10 to the eighth. There we go, rearranged using the commutative property. So now 5 times 6 is 30. And using property of exponents, this would be 10 to the 12th. The only problem is that this doesn't follow the rule where you have to have only one digit in front of the decimal point. So we need to somehow make this 3.0 instead of 30. And this is sort of tricky. Clearly we need to adjust this exponent by 1. But then we got to decide, well, should I add 1 to the exponent or subtract 1? And to me, it just takes like sort of guess and check or trying it out. That if I want to make this the same number, remember this is going to have 12 zeros behind it, right? So it's 30 and then 12 zeros. Well, I would need to make this 13 then, because then it would go 1, move the decimal point 1, and then the 12 zeros. So it would add 1 to that. Let's try another one, see how that works, because it might not be the same with negative exponents. Let's see. The commutative property stays the same though. So this would be 8 times 3 times 10 to the negative third times 10 to the negative second. So 8 times 3 is 24. And then this would be 10 to the negative fifth, because I'm just adding those exponents. But I need this to be 2.4 to follow the rules of scientific notation. All right, so 24 times 10 to the negative fifth, I'd be moving this decimal point back 5. So 1, 2, 3, 4, 5. So I would have these 3 zeros in front. So I, again, just like this one, I need to add an exponent, but adding to negative 5 makes it negative 4. So 2.4 times 10 to the negative fourth, if I start here, would give me that same location for the ending decimal point. A little tricky, but not too bad. Let's try these group works together just to make sure we're all on the same page before we start practicing on our own. Write each of the following in standard decimal notation and then state these numbers in words. So 10 to the 6th power means a 1 with 6 zeros. And a 1 with 6 zeros is 1 million. A 10 to the 9th would be a 1 with 9 zeros. And I specifically picked the ones with multiples of 3 because I wanted to make sure we knew that difference between a million and a billion is 10 to the 3rd power. If I multiply by another 10 to the 3rd power, then we get a trillion. So if 12 zeros makes 1 trillion. Huge. Okay, let's write some of these in scientific notation. If you want to try them on your own, you can always pause the video, try them, and then check. That would be a good way to see if you're getting it. When I do these, I always start by writing it with that 1 digit before the decimal point. And I know this is going to be a positive number. I don't know if it's going to be large or not, but it's going to be positive because this is a large number. So we just need to figure out from this location, how many decimal places did I need to move to get it to the end? And that would be 5. So it's 1 5/1000 times 10 to the 5th power. This next one, I know I'm going to start with 2.56. And I know it's going to be a negative exponent because we're starting with a small number, a decimal. And the number of places I need to go is back 3. So -3. Great. Again, if you want, pause the video, try these on your own. This one says 3.091 or 3 91,000 times 10 to the 8th. So I'm going to take this decimal place and move it 8 to the right. 8 right. So 1, 2, 3, 4, 5, 6, 7, 8, and then fill in with zeros. So after the 091, there'll be 5 additional zeros. And then we can figure out what this is after we put in some commas. So it's 309,100,000. 10 to the -4. The -4 is going to move the decimal 4 to the left. So we're going to start with 5.3, but then that decimal moves back 1, 2, 3, 4. And we got to fill in with zeros. So it'll be 0.00053 for our answer. Negative exponents make smaller numbers. All right, last one, let's try multiplying. This one's actually not that bad because 2 times 3, remember I'm just going to first rearrange these. 2 times 3 is just 6. And then if I add the exponents, I get -16th. I don't need to adjust that at all. It's already in scientific notation. If it helps you to think about it, you can write it as 6.0, but that's totally optional. This is still scientific notation as well. Let's do one where we have to adjust though. So 4 times 9 times 10 to the 5th times 10 to the -2nd. Ooh, this one's a little different that we're combining positive exponents with negative exponents, but it should still work the same. 4 times 9 is 36. If I add these exponents, we get 10 cubed. But now for scientific notation, I need it to be 3.6. So this would be 36 with 3 zeros. So to put the decimal point here, we would need 4 because I'd move it past the 6 and then the 3 zeros. So it'd be 3.6 times 10 to the 4th.